Hey guys, it's Chris here. Let me know if you guys can hear me properly. We'll just want to double check that the audio is working. Happy Friday. Here, actually, let me take this for a sec. I'll show them around the shop. You probably are used to seeing our old setup, and we worked a couple late nights in order to move into the new area as quickly as possible. You can see this is our new shop area. Ooh. Tools and whatnot. Is the sound working? Oh, he says loud and clear. All right, I think we're set up then. Can you hold that down again? Okay, well, we've got a couple things on the schedule today. I'm going to try to make sure that everything is covered in terms of the basics of how to use your machine. And I figured the first place I would start is actually with machine maintenance, because this machine, we run it almost all the time. We use it to make the dust shoes, and so it gets quite dusty and dirty. And actually, when I was setting up for the live stream, I noticed that there were some parts that were loose on it, so I figured I'd leave them loose and wait to show you guys how to do it. So first I'm just going to move this piece of material out of the way so that you guys can see better. So this is our machine setup, and whenever you're coming fresh to your machine, there's a couple really important things that you want to check in order to make sure that it's operating properly. And it has to ensure with the fact that nothing's going to fall apart while you're cutting, and also your machine is going to be working as precisely as it can. And so the two primary things are going to be the anti-backlash nuts and the V-wheels. So usually what I like to go around and do is I like to push back and forth on the gantries of each axis. And I'm not sure if you can see, but this is actually wiggling back and forth a little bit right now, ever so slightly. You can feel it more with your hands, and you can kind of hear it as well, that it's got some movement back and forth. And so I've just got the size Allen key to use, and I'm just going to stick it into the set screw in the back there, and I'm just going to tighten it just a bit of a turn, just a small amount, and then I'm going to go and feel it again. And it's still rocking just a little bit, so I'm just going to give it a bit more of a turn, and it's still rocking just a little bit more.
I think you're rocking the table.
There we go. Now it's tightened up. I can't hear any looseness. Like, I can't hear the rocking sound anymore. So now I know that the anti-backlash flange is actually tightened up against the screw. And so this is going to ensure that there's no looseness in the cuts when I'm making the cuts. So now that I've checked that side, I want to make sure I check the other sides as well. So this one also is a bit loose. You can barely hear it. So I'm just going to go in and tighten this down. There we go. And there's really no hard and fast rule here, other than, like, you don't want to over tighten it, and that's why every time I'm feeling these out, I am rocking it, and I'm making sure that it's still loose, and then I'm tightening it just the smallest amount of a turn, and then I'm feeling it again. and then I'm turning it the smallest amount again, and I just keep going until that rocking noise is gone, and I can feel that it's not moving back and forth anymore, and then that's where I know to leave it. So I'll do it on the Z-axis. Z-axis is very tight. X-axis is also tight. So those are the anti-backlash nuts are all tightened. The next thing I want to go around and check is the V-wheels. So for that I need, I got the larger size Allen key here. Where's the Longmill wrench? Let me see.
You want me to just use a regular wrench for now?
Yeah, I suppose I don't actually. Use this guy. I suppose I must have lost our Longmill wrench somewhere in the move, which sucks. They're very, very handy for doing these adjustments. There we go. Alright, so I have my 4 size Allen key and my 8 size wrench. So when I want to check the tightness of the wheels, this is also, it's something that you're going by on feel. And the feel is basically, can you move the wheel with your hand so that it's not really easy, but it's not impossible to move either. And so I'll start again on this gantry here. And what I'm going to do is I'm going to check the top wheels first. When I'm checking the top wheels, I'm going to actually pull up on the bottom of the gantry to alleviate some of the weight that's on the gantry so that I can, because the wheel might feel tighter than it actually is if the weight of the machine is pressing down on it. So I'm just going to hold it up and I'm going to go to twist it. And this one, I have to work kind of hard to twist it, but it still rotates. And I'm going to try this back one here. This one, I can twist it quite easily actually. And so this one I can tell is loose. So what I'm going to do then is I'm going to stick the wrench on this side and the Allen key on this side, and I'm going to open the wheel up. I'm going to loosen it, and then I'm going to rotate the wrench just a little bit and then tighten it back down. And as you guys know, by rotating the wrench, it will be using the eccentricity of the nut in order to clamp down better. And now I'm going to go feel this, and it looks like it's still a little loose there. So once again, this is one of those things where you just kind of like take your time with. I think I'm actually, let me see here. Let's see if I've got good there. Oh, that's still quite loose. I believe okay, now that I would say is a little bit too tight. Like I have to really try to rotate that even when I'm pushing the weight up off the machine. So at that point, I can just back it off a little, tighten it back down, and now that's at a good tightness. So this is something that, like, you guys are probably wondering, like, how often are you doing this maintenance on the machine? Well, it depends on how often you're using the machine. It's not really a hard and fast rule on, like, certain number of days or certain number of weeks or what have you. It's if you're using the machine more often, then your V-wheels and your anti-backlash nuts are going to wear out faster. It could also, like, the climate that the machine is running in also has an effect on these maintenance issues that you want to run. So Let me just go and check the other wheels to make sure everything else is, oh, this one's quite loose. Back one here is good. There's probably some looseness in our setup here because the machine moved around quite a bit to get it from the old space to where it is now. So that has an effect on it as well. And the reason you only need to check one side is because if I'm pushing up to negate the weight of the machine on the bottom, then as long as these top two feel good, then once I let go, the bottom two should also feel good. So that's if you would like to, you can also be double checking the bottom wheels. They should also be able to move quite easily. Actually, I can feel this back wheel is very, very loose. And so that means I should be tightening down the top some more on this wheel here. Okay, I might have gone a bit overboard on that tightening. A little bit less than that. Yeah, that's good now. Okay. And I'll just double check these wheels here as well. Okay. Yeah, these are all looking good right now. Okay. Before I move on, let's see if there's been any comments. Okay. I don't see anything. All right, we'll keep going then. So the other thing that you want to check as a maintenance run, well, there's two other things. One is looseness in any of the parts, and the other is the cleanliness of the rails. So in terms of the looseness of the parts, you're mostly just you can mostly just kind of go around and go to any of your general components and just try to move them around. I usually focus on like the drive systems. Most of the components are held in with nylon lock nuts, and if you assembled them with tight lock, then that would also be held in place as well. I think the only parts that come loose more often than not is maybe like the bolts that hold the dust shoe mount in place. But yeah, you can see that was very quick. I just kind of went over and felt if anything was loose, and it all seems pretty tight. And the last thing I'm gonna have to do now is clean the rails. These ones aren't very dirty right now, but if you can get a close shot of you can kind of see the blackness on the rails. Let me see. Oh, you can see it at the back there much better. So you can see there's kind of this, here, can I show it from this side? Can you see the blackness here on the rail, these little specks? So this is mostly coming from dust and debris that is flying off when you're cutting on the machine, landing on the rails, and then the wheels pack these down onto the rail. So, but it's very easy to remove. Give that back over to Andy. The way you need to remove it is you just use any like dull object you have on hand. You can use a plastic scraper, a toothbrush, something like that. I actually use these wooden discs because they come out in the middle of the dust shoe. And the thing you just don't want to do is use like a steel tool or something like that, because then you're gonna like start to mar the aluminum. But basically you just want to go around and just push against the particles that are built up on the rail, just to kind of knock them free. And you can see that they just kind of fall off quite easily. I'll do that at the back here too. And the reason for cleaning off the rails is just because the if it starts to really build up, like the current state on our machine, this is probably completely okay. But if it starts to really build up and you tension your wheels appropriately, then essentially it's hitting these little bumps on the rail that are wider than the rail normally is. And that's going to cause issues with the reliability of the machine. If it's a really big buildup and your wheels are quite tight, it's possible that the motors could even torque out on the grime that's been built up. One other note that I would like to make is remember not just to clean the top of the rail, but also the bottom of the rail. And don't forget the x-axis rail as well. You'd think that the grime wouldn't build up on the bottoms, but it certainly does. So it's good to occasionally check out the bottoms of your rails as well. And bottom of the y-axis rails as well. Now, once again, this is directly correlated to how often you're using your machine. If you're not using dust collection, then you're going to have to do cleanup on these more often than if you are using dust collection. You can see it's kind of built up here on the disc, and you can see the particles are kind of loose on there. But yeah, that's about it. You should be able to put your hand on the router here and move it around and feel that everything's quite tight now. Nothing should be able to move around. I think the only other piece of machine maintenance that you do much more occasionally than this main set of steps is occasionally resurfacing your spoil board, which would probably be a good idea for us. This is a very well used spoil board. So those are the steps that I can think of for now. How about we switch over to setting up UGS? We'll share the screen and then you can see what I'm doing on the computer. Oh, we got some questions. The wire run along the Y rail attached to the front foot. Oh, are you talking about the drag chain mount, the wire here? Well, all right. Well, the machine is set up the way it's supposed to be set up in the way that you see it. Random Thunder, to answer your question, as I mentioned before, this is something that is kind of up to your discretion as a machine owner. You know, something like the gunk building up on the rails, that's going to be very visually noticeable when you're using your machine. Something like the anti-backlash nuts and the wheels, that's something that is like also quite noticeable if you come to your shop in the day and you go up to your machine and you like go and you try to move the gantry and you can feel it moving around, then like you know it's loose, right? And then you know that you need to tighten it. So it's pretty simple to do. You just walk up and you try moving this, you try moving this, try moving that, try moving that, and then I also occasionally go around and I just try to rotate the wheels. And it's basically just a 1 or 2 minute process that I follow. Even though we're running the machine quite a few times a week, I usually only check up on our machine, I would say every other week. But
I think the last time I messed with did the checkup maintenance stuff is like a month and a half ago. So
yeah, and then I think I did it last time I did it was like a couple weeks ago, and now I've just done it now. So But it really depends. Like if you're trying to cut things that are really, really high accuracy and you want to ensure that your machine's always dialed in to get those really nice cuts, then you might want to consider incorporating it into even your like daily cutting regimen. So it's really up to you to decide on that. Okay. So I'm going to move on now to, oh, hey Louis. I'm going to move on now to showing off UGS. So we're just going to share my screen here, and I'm going to grab a seat and show you guys what's going on. So on my screen right now, I have got UGS Classic and UGSPlatform. And I'm just going to open them both up fresh to show you what that looks like and what kind of stuff you can do inside of them. And after that, I'm going to show you how to do some customization with them. And I'm going to show you how to kind of start using them to make cuts on your machine. So before I dive into this, I want to remind you that there's actually a page that we have on the resources, and this page on the resources shows a list of all of the different interface softwares that we've tested with our machine, and you can use. If you don't want to use UGS, you can use one of these other ones, and they have their perks. And some people prefer one over the other. I know a couple of our customers really like using CNCJS, but keep in mind that it's like a web-based sender, and some other people like using VCNC or Candle. We prefer Universal G-code sender, and so that's kind of why we show you how to use it. So check this out if you want to try out another G-code sending software.
Quick note, when you're doing the screen stuff, the frame rate on it is pretty slow. So try to not do any movements that are too fast. You can see on the live stream there.
Oh, okay, I see. Okay, so I'm going to start by opening the classic version of Universal G-code sender. You can see it here. So I'll just double click that to open it up. Sometimes you get this message on configuration. This is something that you don't really need to worry about, so you just click no. And because the version of UGS that I downloaded is a nightly build, which basically means that it's like Universal G-code sender is always being updated with new features, and so basically they will constantly be updating the features, and that'll be called the nightly build, or like as the most recent release of the software. But you can also always download what's considered the most recent stable version of the software, because you can imagine the most recent version of the software, if they just release a new feature, it's possible that there might be bugs with it. So I just say okay. So right when you hop into Universal G-code sender, you'll see basically everything's grayed out, and you'll want to begin by connecting to your machine. So I've got the machine, the computer I should say, plugged into the control box with the USB, and I've got the machine powered on. And so immediately what I'll usually do is I'll hit this refresh to get the computer to kind of search for all of the available inputs that exist. And then I hit this drop down, and I can see that the machine is popped up here as COM231. If you're on the Mac, it'll look a little bit different. But usually you can kind of like, if you're not quite sure which one it is, you can kind of go through each of the options, and eventually you'll find one that will open up a line to the machine, and you can tell that it's working because you can actually move the machine and make sure that you've set the baud rate to 115,200, and then I just click open. So I don't know if you guys heard that, but you can kind of hear a little thump that comes from the machine when you open the communication line to it, and so that's a really good sign. And you can see I've got this opening message here which says, okay, this is the Longmill, and it kind of hits me with this opening firmware message, and so that kind of tells me that everything's connected properly and I should be good to go. So let me introduce you to what UGS Classic has available to it in terms of control with the machine, because this software acts as your machine interface to the Longmill. It enables you to do any sort of the control or the file sending or anything of that nature to act as the bridge between you and the machine. So I'll start in the top here. This is a machine control tab, and usually the first place that I start with is actually on the right side here, which is where you can do the machine jogging. So as long as your feed rate is set to somewhere above 1,000, because if it's below 1,000, then the machine feed rate will be too low for the axis to actually move. So I've got it set to 10,000, which is kind of an arbitrary value. Then I should be able to move the machine around. You can see right now, if I were to click movements in the X or the Y, which are this kind of cross layout here, it would be moving 10 millimeters because my units are millimeters and my step size is 10. And if I were to move in the Z, then it would be moving by 1 millimeter at a time. So I don't know if we have a view. Can we? Oh,
yeah, it's funny.
Okay. So if I go and I press the Y minus, you can see that is moving by 10 millimeters at a time in the Y minus direction, which is towards you. And if I hit like X plus, then that's going to be moving the X axis in the positive direction, which is to the right. If I hit the Z, you can see it's moving by just 1 millimeter up or down. And you can kind of just toggle this around. And so that's very simple machine movements that you're achieving. And if you want to move by like a little bit faster, you can kind of like click it a little bit, or if you'd like to set this to a lower number, like 1 millimeter, you can press and hold. Actually, I think it's like, I think I have to set it to a minimum of like 5 millimeters. It'll just kind of keep jogging based on the quantity that you enter in. So if you want to make any faster movements, then you can set it to a larger quantity and then make it jog by that amount. So it's quite simple. This kind of allows you to just generally move your machine around to the different locations when you're trying to start your cutting job. And the classic version, the jogging is a little less responsive than the platform version, just because it's a slightly older iteration of the program, and so just bear that in mind. So I'll move over to the left side here, and you can see that, actually I'll point out here that now that I've moved around, it's logged my movements in terms of the position of the machine. And so that kind of shows up here. And you can see that when I'm moving it over here, the state turns to a jogging state. And then once it reaches its position, it's back to idle. Then the last two parts are kind of up here and down here. Up here allows you to kind of be resetting the position of your machine. So you reset 0, or you can reset each axis individually. And so if I reset my 0 here, and then I move the machine back, and I move it over, and I move it up, and then I tell it return to 0, it's going to return back to the 0 position that I set before. So that's pretty straightforward. And then down here is where you do your file sending. So if I were to want to load up a file, I can browse, and I think I have a file loaded up on here. Yeah, like this guy here. And so before you run the job, you can open up the visualization window, and it'll basically show this yellow stick here is where the cutting point is of the machine, where the bit is going to be, and this shows how it's going to move around to cut out the file that you want to cut out. And you can see that if I go and I jog the machine over and back, and I open this back up, you can see now that it's moved that yellow cutting bit to correspondingly away from the 0 point. Because the 0 point, I haven't changed it. You can see here, it says it recognizes that I'm offset by 40 millimeters in the X and the Y. So that's 40 millimeters and 40 millimeters in the visualizer. And so if I hit reset 0 and I tell it, no, this is my new 0 point, I'll minimize this here so you can see this happen live. If I hit reset 0, then now it says, oh, okay, now you're back at your 0 point. Anyway, I'm not going to talk anymore about this because most of our customers, I think, use UGSPlatform, and I'm going to explain more of the functionality in UGSPlatform. So I'm just going to close the connection, and close this up, and I'm going to open up UGSPlatform.
Do you want to take a break and show them the vertical?
Well, are people asking about that? Okay. Yeah, so I'm making how are you, Louie? You camera shy dog. This is a vertical mount system that I worked to put together. I am going to be making a video on it. Well, I've already started working on the video on it, and so I'm going to be releasing that as soon as I can. But it's very nice. It's very nice and solid setup. It's got a good sized waste board. You can see that even with the power off to the machine, it's on just a slight angle. It's able to stand up on its own, and it's also got a little shelf here, so that when you load the material onto it, the thing about a vertical setup is it's hard to hold the material in place while you're finding a way to fasten it down to the table itself. So I've got this shelf here, and it's actually got adjustable height to it, so that if your material is a little bit longer, then you can kind of toggle the shelf height accordingly. It's also nice to hold your tools and stuff up here while you're fastening everything in place. All right, back to
the regular programming.
Your regularly scheduled program. Okay, so you can see that UGSPlatform is loaded up, and and obviously it gives me the message as well. So for UGSPlatform, we use the nightly build of version 2 for November 15th. That's the one that we've been running for a long time. Some people ask like which one we use, so that's the one we use.
But the one that's on the website is August.
Yeah,
I think that one's just a random one.
Yeah, this one's kind of more of a random one. I think obviously since it's constantly in development, they're like each version of UGS, like in terms of the nightly build of UGS, will have like certain things, like certain issues with it. But like this is the one. This is like the one that we've just been running. In case you're wondering, I wanted to show that when it comes to UGS, you can either be here and on their downloads page and get their most recent nightly build, or the previous stable versions here. Or if you go to the GitHub here, you can also download previous versions of it as well. So I've got UGSPlatform open. You can see that there's a little bit more happening here. It's why I kind of wanted to start with UGS Classic, because it's a bit more digestible. But by having a lot more content, Platform also has a lot more in terms of features available to it, you as the user. So first you want to start by connecting to your machine as we did before. So we're going to start at the top here, hit the refresh, toggle down, we can see the machine here, and then we're going to go over to this little plug symbol here and plug in. We're going to connect to the machine. And once again, you can see it's popped up here, our opening message, and you can see we've got this little orange symbol that has appeared that shows that the two ends are plugged in, and that means that we're good to go. So similar to UGS Classic, we've got a way to jog the controller, which is this window here, the jog controller window, as well as we have an ability to send files, which actually happens through here as well as through here. And the visualizer is already popped up here for us to use as well. The cool thing about UGSPlatform is that you can customize it to whatever configuration you want to suit your workflow, so that you're seeing the information that you want to see when you're using your machine. So if you're wondering what windows you have available to you, if you click on this window tab, you have the visualizer, you have the controller state, which is down here right now, macros, which only more advanced users would use, machine state, the console, which is your output down here, overrides, which I can explain later. You've got things like your common actions, which is like your reset 0 and your return to home, your send progress, which is your the progress of the file being sent, and you've got some other plugins like a gcode tiler, your jog controller, a dowel maker, which we've never used, but some people do, a probing module, which I'm also going to explain, and an auto leveler. So if at any point in time you don't see a window here that appears up here, so for example, I don't see the probing module here, then I can go to the window, I can go to my probe module, I can click that, and now you can see it's going to pop up here. You can also get rid of any of these windows at any point in time and drag them into different positions as well. So for example, I don't think I really need this welcome page, although you might want it, but I'm just going to get rid of it. I don't think I need the workflow helper. I like having the visualization window being quite large, but maybe not that large, so I'm just going to grab these lines here and kind of stick it into the corner. What else? Well, I use jogging all the time, so I don't know, maybe I'll grab this and maybe I'll make it a tab up here. I don't tend to use macros, so I'll get rid of that. I like to see my controller state, so maybe I will make that a window further up here that I can see much more easily. What else? Overrides are quite useful. Maybe I'll make that a tab that's closer to my jog controller. Common actions are also quite useful. Maybe I will make that its own window down here. So you can see I can do basically anything I would like to make this work in a way that I want it to. It's and so let me explain. So now that I've set it up in a way that I tend to use UGS, I can explain to you what the use case is for all of these. Up here you've got your jogging, which is the same as what we used in UGS Classic. And then here you've got your machine state, which is also available in UGS Classic. It's going to show you where you're currently positioned. You can see I've got my visualization window here. If you would like to reset your axes, you can actually just click these buttons here. So right now it thinks that the Y is at 132, but I want to set it to 0. And now you can see that that yellow point is set to the 0 point. You can also tell it that it's somewhere else by typing a position in if you'd like. And you can see it's now moved it up by that amount. But I'm going to 0 it. This is the progress as the file's being sent, and these are the common actions once again. And I think that's pretty straightforward. What I like about UGSPlatform is that when you go to jog the controller, it is set up in a way so that when you press and hold a button, it'll do a constant jog, and then as soon as you let go, it stops. So this is actually very useful because then you don't actually have to set your step size if you're just jogging the controller around or jogging your machine around. You can set it up wherever you want to by just pressing and holding the buttons. And you can do that in any axis. So that's quite a nice feature. And that means that, as I said, that means that you don't really need to bother about setting your step size. You can just kind of move it around as you need and place it where you want to place it. Is there anything? Do any of you have any additional questions about the software? I'm going to explain the probe module in maybe 10-20 minutes. And I'm also going to run a job, so you guys can see me actually using UGSPlatform to run a job. But for the time being, is there anything that you want me to point out? I see, Keith, I see that you want me to show off the pendant feature. I think while I'm waiting to see if there's any other question coming in, I will set that up actually. So let me see if I can get it working. So the way the pendant feature works is you basically click the pendant button here, and then it gives you a window that has an IP address on it. And well, let me open up a new tab. 192.
Someone's gonna start controlling the machine. Well, it's a local network, right?
Yeah. It is.
How to hack your Longmill.
Okay.
It's like a fixed focus, I think.
Oh.
Here, you want to just
basically? Well, you don't need to really see it, but I've just opened up my web browser on my phone, and it's just set to the same IP address as. Oh. It's set to the same IP address as what's on UGS. So if I click enter, then it should be able to find it here.
The Wi-Fi here is a bit slow.
Yeah, we're kind of in the other room. Oh, there we go. There we go. So, you can see you've got a more generic kind of call out here, but you still got tabs to jog and do macros and send files and stuff. So if I click the jog, then if I press on the X or the Y, you can see that this is fully controlling the machine, and I'm also getting live feedback on the position of the machine right there. And you should be able to see that if I'm going to close the pendant window on UGSPlatform, you should be able to see that the coordinates that show up on my phone here match what show up on the computer. And if I jog here, you should see on the computer that it's recognizing it as a jog, and the coordinates are changing appropriately. And I can also reset my 0 and set my feed rate and stuff like that. So I'll like reset the 0 here. Now you can see on the computer it's also recognized that I'm back at the starting point. Let me see. All right, well, I guess I'll move on for the time being. I think if you have any other questions that come in, I can answer them. So what I wanted to show you guys is I was just going to very briefly talk about work holding methods. I was going to talk about the bits that we use, and I was also going to, oh yes, I was going to show you the touchplate. So, as you probably saw before, the go-to work holding method that we like to use here, and as you can also tell based on the number of holes in our wasteboard, is we like screwing things down. It's quite easy. It allows you to mount things in place without having to really think about it.
Unless you go and drill, cut into where you drilled your holes, right?
Yeah, the only downside is like you kind of have to be aware of where your screws are when you're cutting, because your bit can run into the screws. So some people aren't very, some people might not feel confident on that. I can tell you that it still occasionally happens with us, so don't be embarrassed about it. You know, it's life. That's life. Sometimes you break stuff, and usually when you break stuff, you learn from it. But this is the type of method that I like to use because it's just like you can run into them, sure, but it's also just so easy. You know what I mean? Like it's so easy to just screw it in, and now it's held in place, and you can do what you want to do. There are some other methods that exist. I don't have too many props with me, but you can use double-sided tape. You can use painter's tape on your flat sheet, and then painter's tape on your spoil board, and then you basically just stick some super glue in between. And if you have a what's it called, like a activating agent, then you can put the super glue on one side and the activating agent on the other side, and then you just stick them together, and it holds really well. For sheet material, that's a really good method. You might also notice that we don't have any T-tracks or anything set up on our machine, or threaded inserts. Those are methods that other people like to use as well. If you have a clamping system set up for your T-track, you can kind of like take your piece of material and hold on to it from the tops and from the sides and from the edges, and that also works with the threaded inserts as well. We're gonna try to set up another video where we can kind of show all of those work holding methods, but personally for us, we have two go-tos. One is screwing straight down, and the other one is hot glue. And the reason hot glue works really well is because you just heat it up, glob it on, and especially for like if you're working with like a cookie, for example, and you don't want to screw into it and ruin it, you can just hot glue the one side down, cut off anything you want, and then you basically just grab like a paint scraper, and then you just kind of get under that and wedge it up. And the hot glue holds it really well, especially woods. The rough surface, the glue can hold really well onto. So that's another good go-to. Let's take a moment to talk about cutting bits. So I've set up some of our cutting bits here, as you can see. And when it comes to the cutting bits, we stock either 1/8" bits, which is these guys here, or 1/4" bits. And this is the shank diameter on the bits. And so the Makita by default and many other routers. Oh yeah, and the surfacing bit. Yeah, here's the surfacing bit. The Makita and many other routers by default have a 1/4" collet in them. We also supply these 1/4" to 1/8" adapters. That allows you to use the 1/8" bits. Let me just explain why you might want to use some of these bits. Let me see if there's any. Okay, still no other questions. Okay. So, the type of cutting that I do, which is usually more functional stuff, like you're cutting through and making stuff, or do I have any other examples here? Actually, let me go grab some examples real quick. Oh, we're going on that. Hey, wireless camera, wireless, let's do it. Ha 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 ha. Who pointed that out? Thanks, Victor, and everyone else.
Yeah, so I realized that the microphone is set up here and not with the camera. So you probably just didn't hear Chris talking for 3 minutes, which is, you know, it's kind of a blessing in disguise. So, anyways, we'll just he'll just explain the stuff that he just said.
Yeah. Okay. Yeah. I'll try to explain it. Actually, did I grab some? Oh, I'm gonna go. Okay, you just stay here 1 sec. I'm gonna go grab the Star Wars V-carving as well.
Okay, bye.
Bye bye.
Well, I guess in the meantime, we can all admire Louis. Hey, Louis, how's it going? How's everyone doing on this Friday afternoon? We have 21 viewers on right now. 20. Okay, well, Chris is coming back.
I'm back. I'm gonna show you some stuff. Okay, I'm trying to be as thorough as I can here, but if I'm missing anything or if you have any questions, please ask me, because I would really like to be able to tell you guys what kind of bits to use in what situations. So, okay, I'll start again because I don't remember how much of it you heard, and I've been talking for a while, so who even knows what I said. Step number 1, we got a surfacing bit. Surfacing is for surfacing. That's basically all you use it for. You use it for setting up your spoil board to make sure it's nice and flat, or let me see if
Flattening.
You can use it for flattening large material. Like this. This is a large piece of raw wood that has been completely flattened, and
Wow, Chris, that's a very flat piece of wood.
it is a very flat piece of wood. And that doesn't have any sanding or anything on it, that's just how it came off the machine. So yeah, surfacing is for surfacing. Alright, that's one bit out of the way. Boom. Flat end mills. These are used, as I was saying before, they more are functional in terms of, like, if you want to be removing material, the flat end mills can remove the most material, and they operate the most reliably, and they just kind of like, but because they're just flat bottomed, it means they can't make anything particularly fancy either. So, as I was saying before, our dust shoe bases here, these are cut out with flat end mills. And the general rule is when you can use a larger end mill, you should use it because it's more rigid, and so it'll cut more reliably. You can usually cut faster with it because it's more rigid. What else? Those are kind of the two main selling points. You can just kind of cut really quickly, and they're quite reliable.
I would mention that if you use a smaller bit, it makes less dust. So if you're not pressed for time, you know, using a smaller bit is also, like for a profile cut like the dust shoe, one of the reasons why we use the 1/8 inch instead of doing 2 tool changes is just because it makes the dust less more manageable, and we just let the machine run, so you know it doesn't really make a huge difference in time.
Yeah, so that's like another contributing factor. So what I was explaining before as well is you can see with the geometry that we have here, you could definitely cut the outside with a 1/4 inch bit, this large hole and this smaller hole here, but the through holes for the M4 hardware, you couldn't cut with a 1/4 inch bit because they're smaller than a 1/4 inch in diameter. So what I was explaining before is you could do this one of two ways. You could either use your 1/8 inch bit to cut the holes, and then use the 1/4 inch bit to cut all the rest of the geometry, and then you're done. Or in our case, because we're kind of just like running a whole bunch, like we're trying to produce as many as we can in batches, it's easier if we don't have to switch the tools out. And so we can just leave it as an 1/8 inch bit, and the 1/8 inch bit can go and it can cut all of this geometry out on its own. It's just that you have to go a little bit slower when you're cutting, because the 1/8 inch bit is it's less steel, it's less material, like you can't force it into the wood as quickly because it can snap, right? This is like an example of what you can do. Like you cut out this perimeter with a 1/4 inch bit, you cut out the little inside of the tray and the holes here, or this sign here where you've kind of got this raised lettering. You use the 1/4 inch bit to kind of rough out the material, but then you use for the small, inside edges and the small lettering here, you would use an 1/8 inch bit in order to cut out all this detail that you need. And then you'd certainly use a 1/4 inch bit to cut out the perimeter to finish it off. This is just a single piece of MDF, and then it was just like hand painted on the top. And this is like an example where if you have an even smaller bit, you can cut really small geometries like this. This is like a pendant that you can use for an earring or a necklace or something like that. Ball mills. Let's talk about ball nose end mills. So with the ball nose end mills, those are when you're trying to get more detail and make some really neat looking things. So you can do something simple with a ball nose end mill. I'll come back to this. This tray, you can see it doesn't have flat corners. Like it's not sharp corners at the bottom of the tray. They're actually rounded here, and that rounding is produced by just running a ball end mill around the perimeter. And so that can add some nice touch to your project. I believe this slot area here was probably also cut out with the ball end mill because it's nicely rounded and has a good contour to it.
That project was done by Jeff. He sells these, so if you don't have the machine, you want to buy one.
Yeah.
Shameless plug.
Buy it from Jeff. Thank you, Jeff. Then you can move on to something like this, which is a topological relief cut. And this is also cut by a ball mill. This is an 1/8 inch ball mill that was used to make this. I believe it was an 1/8 inch, or do we use a tapered
1/8
bit?
inch.
Okay, so this is an 1/8 inch, which we sell. You can see the difference. This is a flat end mill.
We have a
Is it
1/4 inch
ball mill?
ball mills too.
Yeah, we do. I don't think I have them here, but yeah. And yeah, so this is cut with a 1/4 inch ball mill. This is cut with an 1/8 inch ball mill. Did you use the tapered ball mill for
No,
this?
that's an 1/8 inch ball mill.
Oh, I used the tapered one for this one. Then you can get stuff like this using the tapered ball mill.
Cool.
Tapered ball mill is it comes down to a 0.5 millimeter radius at the end. Are there any questions?
How do you make a wasteboard with T-nuts?
Oh, okay. I will get back to that. Last but not least,
V-bits?
V-bits. We've got actually 3 types of V-bits. We've got the 90 degree and the 60 degree, which very useful for sign making. And then we got the 30 degree, which are for more precise work. I feel like not a lot of you would benefit from using the 30 degree. They're very useful for cutting like really small and fine detail.
The Lake Ontario lettering was done with the 30, but
Yeah.
that's in the other room.
So yeah, if you've got like really small and intricate like hand lettering that you want to engrave, then the 30-degree V-bit would be useful. The thing about it, right, is like if you've got really thin lettering, then if you're using like one of these guys, then they can only penetrate just like the smallest amount in order to get that width. And so since you don't get a lot of depth to the cut, it doesn't make the lettering as clear. So that's kind of when you start working to reduce the angle. So if you're working with lettering and it's not coming out clear on the 90 because the lettering is a bit finer, then you can move to the 60. And then if it's still not fine enough, you can move to the 30. So that's kind of like how that works. Do you remember what angle bit was used for this guy? If I had to guess, it would be a 60.
Yeah, I'm pretty sure it was the 60, also made by Jeff.
Oh yeah, also made by Jeff. So you can see that like if I've got this 90-degree V-bit here, and I'm trying to get in on all of these small details, it's kind of hard to kind of get into all of these little nooks and crannies because it's kind of got like quite a wide angle that you're trying to get into it with. Whereas with the 60, you can see that you can kind of get in much deeper and cut out these small details more easily. But at the end of the day, they're both very useful, the V-bits, for lettering and sign making. That's a lot of where their use comes from. You can also do like stippling, like that. And this is basically cutting out different size hole in order to cut out an image.
Yeah.
Nikola Tesla.
Inventor of the electric car.
Yeah. I don't know if you guys have heard of him. He's kind of all the rage nowadays.
Can you talk about upcut, downcut?
Oh yeah. I'll talk about that. Let me clear this out. You can also see you can do stuff with these are cut out with an 1/8 inch end mill.
No, those are 2 millimeter.
Oh yeah, sorry, 2 millimeter. I think this one here is probably the 1/8 inch. But you can get some reasonable detail with smaller end mills as well. But just as well, you can make these just as easily with a V-bit. So it's up to you. Okay, I will speak on upcut versus downcut. I've got a piece of sample plywood here. So we sell some of our bits in both upcut and downcut flavors. And the differentiation between them is basically where the sharp edge is. For the downcut bits, the sharp edge is shearing the material downwards, so it's actually pushing and shearing the material in a downwards direction. And the upcut, it's shearing the material in an upwards direction and pulling the material in an upwards direction.
Dust comes up versus down, right?
Yeah. So you can imagine with the upcut, if you're pulling the material upwards, then the dust is going to be flying out the top. But if you're cutting something like plywood or a soft type of wood, you can also imagine that it's going to create a fuzzy edge when you're cutting your detail out. If it's pulling the material up, it'll kind of create this fuzzy perimeter around where you're cutting whatever sign or geometry you're trying to cut out. So vice versa, with the down cutting bit, if you don't have the material straight up against your spoil board, if it's offset just a little bit, then when you're cutting down, you're going to get a fuzzy perimeter that appears on the bottom of the material. If you do have it straight up against the spoil board, then this helps to reduce the fuzziness on the bottom, and that's why some people opt to use a downcut bit over an upcut bit. it's almost purely to make the sanding and the finishing process faster on your end, like to make your life easier. Because the downcut bit, there's a disadvantage in that it's kind of shoving the sawdust into the cut, and so you don't have good chip evacuation, and so you're kind of relying on your vacuum to try to like pull it back out. But because it's kind of shoving the dust in there, in some cases, like you would never want to use it for aluminum, for example, because for aluminum you really need good chip evacuation. For wood, you still need to watch out that like you're keeping an eye out on your cutting to make sure that it's not going to get jammed up with the dust that's getting stuck inside. But the big perk to it is you're not going to get fuzziness on the edges of your material. So that requires much less finishing. This is also why more industrial machines or people that are running larger cut jobs will sometimes use what's known as a compression bit, because as I mentioned, if your spoil board isn't completely up against your piece of material, or let's say even you're using tape to adhere or like hot glue to adhere to the spoil board, then you'll get fuzziness on the downside, just not on the upside. But with a compression bit, it's half upcut, half downcut, and so it kind of pushes the material in towards the center, like the sawdust in towards the center, so that removes fuzziness on both sides. I hope that explanation is adequate for you guys' understanding. Let me see. Carbide create tool libraries for the CNC bits. No, we don't. I don't know if we can make it.
I'm pretty sure if they use the default, it'll work fine. Like the size wise, but the speed I find that the speed that they use on the Shapeoko is maybe like half to a third the speed that I usually run it at on a Longmill. So if people need to find recommended feeds and speeds, the ones that we have on our website are good conservative starting points that they can use for the general. I think we have like general size of the tool and the speeds on there.
Yeah. Okay, we'll wait. Oh, thank you very much, Peter. I'm glad that you thought my explanation was clear. Let me have some water here. We'll just wait to see.
Just so you know, when you say something, there's like a 1 minute delay.
Yeah, I know. That's why I'm waiting.
Yeah, so you gotta wait.
You should show your face to the camera. I don't think people have seen you yet.
I don't know if I want to scare people.
Let me see here. I'm just going to bring up a page here.
I'm just a guy who's trying to have a steady arm. I'm betting that the people watching the live stream think I'm having a seizure.
You're having a Caesar salad?
Seizure.
Seizure?
Seizure. Someone's asking, how do you make a job that has operations on two sides?
Oh, like flip cutting?
Yeah.
I think. Well, I won't try to explain it to you now because it's a little bit more advanced, and I'm trying to save this video for some more basic setup related to like basic tools and work holding and stuff like that. If you want to do flip cutting, there's a lot of guides that you can find online, and I'm also going to be working on my own guide on how to do it as well. But the key essentially is to just ensure that when you're flipping the material from one side to the other side, that you're really accurate with the alignment from one side to the other. So you can use that with hard stops, or you can cut in like dowel pins for locating.
Yeah, you have the what do you call it? That like the water grate thing that you cut out on both sides.
Yeah,
Maybe there's a video on our YouTube that you could probably find on how you did that.
yeah. I don't think I really explained it super in depth, but there was a sign that I made. I think it was like I called it like a piece of wall art. I made it out of African padauk, and that required that I cut it in from both sides. And so for that setup, I basically just tried to ensure that my material was exactly to the dimension that I expected it to be, and as square as possible. And then I basically just I actually just hot glued 2 hard stops, one on the left side and one on the bottom side, to align the material to. And then I clamped it in place, cut the one side and flipped it over, clamped it. Actually, no. Did I clamp it in place? I might have actually glued it down. I think I actually glued it down.
I think you glued it on the sides to make sure that the bottoms were flush to the wasteboard.
Yeah, I can't exactly remember, but
there's another way that I use, which involves designing in holes for a pin, so you can flip it around the pin, so it doesn't matter if your dimension of the material is irregular. But that's like a little bit more advanced, and you need to use some CAD and some math to figure that out. So
yeah, it's quite a few more steps. I would say if you are trying to do 2-sided cutting and the 2 sides don't have to match up even like perfectly, if you're just doing like let's say you just do the one side and it's a sign, like just a regular sign like this, and then on the other side you just want to do like an engraving of your name or a logo or something like that, then that's like a very simple thing to set up, where you just run this job, and then once this is done as like a finished piece, you just hold it down on the other side. You set your 0 as like wherever you want to start on the material, run the job, it'll do the whole engraving, and then you're done. So then that's a much more simple way of setting up a 2-sided cut. Okay, I think we're going to move on now to
starting a job.
the sample job that I'm going to do. Yeah. So, actually no, sorry, I was going to do the touch plate next. So, do you mind switching over to the computer? Okay, so basically I'm here in the resources, and I've gone to the page on touch plates, and I've just scrolled down here because this is kind of like the page that has all of the information you need to know on setting up a touch plate. So I'm going to set the touch plate up because you kind of need to enter some parameters to begin with. And then I'm going to show you on the machine the touch plate in action, and also I'm going to see if I can cause some issues, like some common errors that you might get when using the touch plate. And I'm also going to try to explain when you might want to use the touch plate and why, because these are just some questions that I tend to get. So, right here on this part of the page, everything in red is stuff that you're going to be entering in. So that makes it very easy for you to see. So I'm just going to kind of minimize this off to the side. And I've brought up the probing module here so that I can see everything. And now I'm just gonna kind of enter in these values. So set my units to millimeters. set to millimeters. Set my end mill diameter. I'm going to be using a 1/4 inch bit for my setup here. So that's 6.35 millimeters. My fast find rate, set it to 150. Alright, set it to 150. My slow find rate, 25. Retract amount to 1. Okay, that's set to 1. And the work coordinates are set to G54 still. Okay, now the offsets and the distances. So these need to be set for all the tabs separately. So I'll just start with the XYZ first. So my probe X distance is going to be 25. The Y distance is going to be 25. The X offset is going to be 10. The Y offset is going to be 10. The direction is going to be negative 15. Make sure it's negative, guys. And the thickness is going to be 15. There we go. So now I'm going to go to my other tabs here, because that saved the values for this tab, but I still need to set them for the other tabs if I want to use these other use cases. So I'm going to go set these as well. 25, 25, 10, and 10, and then 15, and negative 15. So now I've gone in and I've entered in all of the settings into the probe module. Now I'm going to, let's do a combination screen view and machine view, but emphasize probably the machine view. Yeah. Okay. So I've got my touch plate plugged into the probe pins on the longboard controller, and you've got your 2 wires coming out here. Oh, you want it? Okay. So there's the magnet, and there's the probe itself, and the banana plug. It's just, you can plug it into either side of the probe, here or here. You need to be making sure that these are contacting each other. And so if you ever are concerned that they might not be working, then what I like to do is I go to the Z probing on the computer here, and what I'll do is I'll have these contacts with me here, and I'm going to just click to initiate the probe. I'm going to raise up my Z axis nice and high as well. Make sure it doesn't run into anything. And now I'm just going to initiate the probing. And when I initiate the probing, I'm going to tap these two guys together to see if it's contacting properly. This should be happening 100% of the time. So if this is ever not working, then that means you might have a wire loose here, or to your connector here. So I'm going to initiate the probe, and you just tap it twice. So it's seeking right now, so I tap it once, and then it goes to find it again. I'll do it right next to the machine so you can see right next to each other. I'll initiate the probe. That's the first hit, and then it goes to find it again, and that's the second hit. So you can see that it's working as it should be, which is very good. Okay. Yeah, okay. So I'll get to showing that. Okay, so I'm gonna grab just a block of material over here. let's go with this guy here. And for now, I'm just going to screw it down to. Yeah, I'll try to screw it down kind of out of the way, so that I'm not ruining the. Actually, I could probably do it over here. That part's already ruined. Okay, I'm gonna bring the x-axis over.
You sure you don't want to use the one that you can actually see the things on?
Oh yeah, we can use this.
That one's like, what? I don't know what happened to that one. Did you try to sand it?
Yeah, I think I was sanding that.
You needed an end mill on it.
No, I don't. No, I'm just kidding, guys. You. Oh yeah, so I was just gonna show. Let me bring this forward. So when it comes to putting an end mill in, there is a button at the back here which secures the collet in place, and then that'll allow you to rotate the nut freely because that locks it in place. So right now we've got our 1/4 inch collet here. So if I were to put in a 1/4 inch bit, then obviously this is going to fit very nicely. So, but if I want to put in an 1/8 inch bit,
This is a 6mm bit.
oh, it is 1/4 inch bit. But if I want to put in an 1/8 inch bit, then that's when I'm going to have to use this adapter. So usually when I'm putting the adapter in, I take the collet out so that I can make sure that the adapter is seated approximately like this. This just allows, because the nut has a bit of thickness to it, this just allows for the adapter to kind of help to better support the 1/8 inch bit at the surface there. And then I also stick in the 1/8 inch bit. This. And you want to stick it in as far as you can go. So that it basically is supporting the whole shaft with the bit, and only if you're making deeper cuts can you bring it out a little ways, but really like this is the furthest out an 1/8 inch bit should go to make sure it's as rigidly mounted as can be. And then I stick it inside the nut here, I hold the collet in place, and then I tighten the nut on.
I'm going to point out that I usually put the end mill into the collet first and then the collet into the big collet.
Yeah, I think you can do it either way.
The reason I do that is because sometimes if if you don't have a good quality bit and the shank diameter is not accurate, then like it's harder to get it in.
Oh yeah. It depends. Yeah, it depends on the tolerance on the shank of the bit. Yeah, you can do it. I'll take this back off to show you what Andy's talking about. Sometimes you might not be able to stick this guy in just straight off the bat like that. So if that's the case, then you might want to put this onto the bit first, the adapter, and then put the adapter into the collet like this. And then you stick the nut in, hold the lock, and you rotate the nut in place like that. Then you tighten it like this. So now you got your 1/8 inch bit on it. But we're gonna, yeah?
Oh, I was just gonna say, typically, rule of thumb is to have like around 3 times the diameter of the shank. Sorry, diameter of shank inside the collet, like 2.5 to 3 times.
Yeah, I mean, like if you're trying to get as much stick out of the bit as you can, then yeah, that's like a good rule to keep as much of the shaft into the collet as you can. But most of the time, you're if you're not going to be cutting super thick material, you just want to try to keep it as far in there as you can, because it just supports the bit better and it'll deflect less since it's got less stick out. So anyway, I'll take this guy off because we're not using it. We're going to use the 1/4" bit. For the 1/4" bit, you don't have to really worry about setting anything up on the inside because you don't have an adapter to worry about. You can just stick it up there and tighten it in place like that. There we go. Does that make sense?
Maybe they should call it end mills and collets instead of the birds and the bees, you know?
Yeah.
Looks pretty good. I'll just move it a little bit. There we go.
Okay, so so I'm going to demonstrate how to probe in all the different ways that the probing module allows you to do, and then I'm going to explain when you would probably use those different forms of probing. So first I'm going to do probe in the X, Y, and Z, so all three of them. And when you want to do this, you basically set up the bit so that it's, roughly located above our logo, the circular logo, and offset by a small distance as well. And make sure that you're taking your magnet and you're clipping it to the collet or the bit. Like, just make sure that it's nicely in place and that your probe is located in place as well. And as I said, you can put the banana plug either from the back or from the side, like whatever is the closest. And then I'm going to go into, I'm in the probe module in UGS, and I'm going to click on the XYZ tab. And then that's going to give me the button that says measure outside corner. And so
I should mention that when you put the magnet, if you put it on the nut, if there's a lot of paint on it and it doesn't conduct properly, then you won't have the probe work properly. So putting it on the end mill might be better, or up on some surface that's not painted. But ours is like pretty worn out, so we're probably good for that.
yeah,
Electricity is weird.
you're just trying to get a solid connection,
And you can always use the test that you were doing earlier, just with you touch probe on the router above. Right?
Yeah. Like if you want to make sure you're not going to be marking up your probe, as I was showing earlier, you can always take the banana plug out and you can initialize the probe and just tap it to the bit and make sure you're getting good contact. And then you can set it up with the actual block. Okay, so now I'm just going to click this and we're going to see if the magic sauce happens the way the magic sauce is supposed to happen.
Contact.
There you go. Are we back online? Okay, it's doing something.
I think it might be back because that's where I was standing just a second ago.
Yep.
We're back. We're back. Excelente.
It blew up. Yes, it blew up. Now we're all dead.
Yeah.
But
Yeah.
we pressed the reset button and now we're alive again.
Yeah, we went and we probed it, and then our whole office just exploded, and that's why probing is just. Oh, hi, Louie. Even Louie's scared. Louie's so scared.
Oh, okay. No sound. How do we get sound? Sound? Can we do the sound?
Even Louie's scared. Seems like we got sound.
Are you guys able to hear? Oh, sound is good. Okay. Should we continue the rest of the live stream?
Louie's going to show you guys how to set up your touch probe on your machine. Right, Louie?
Sound is okapi.
Okay, okapi. That's the best sort of sound.
All right, let's press that button again.
Let's carry on. Let's pick up where we left off. Okay. So, where we were at, we had set up the touch probe.
Let's run the
UGS.
probing again.
Let's
Just for funsies.
Let's run the probe and you guys can see it once again in action. I'm just going to click the same thing in UGS, which is measure outside corner button. Is it there? Lit up? Okay. Let's click it. Okay, so now that the probe has happened,
Just checking the Wi-Fi.
you just remove the block.
Okay, our stream's good.
Seems good? Okay. We're going to remove the block here and remove the magnet. And then back in UGS, you'll notice that in your coordinates, it's going to be offset by around like 3 to 5. Like this will depend on how closely you were above the circle logo.
What's 0 point?
It'll be like around 3 or 5 in the X and the Y, and then about 20 in the Z. And so once you hit return to 0, this is now going to put your end mill at the corner of the material. You'll see. I'm going to hit it right now.
I want to make a clarification.
Ooh.
Those dimensions, when after it's done probing, the machine goes back to its original position.
Yes.
So even if you start it from like, let's say 30 millimeters from the circle on the z-axis, your coordinate will be at 30.
Yeah,
Which
yeah.
makes sense because that coordinate is the distance away from the origin point that it's just measured, right?
Yeah, so the reason I wanted to point out those numbers to you guys is because if you feel like for some reason the probing has gone incorrectly, even though it hasn't given you an error, you can always check those 3 numbers. And as I said, they should be around like 3 to 5 or 7 or something like that for the X and the Y. They could be like very small negative numbers as well, like maybe negative 0.5 or negative 1. And then the Z is going to range from being like anywhere from like 20 to like 30 or 35, depending on what height you started at. And that's just to act as a way of confirming that like it has probed properly, so that when you hit return to 0, it's going to return to the corner of the material. And you can see it's returned exactly to the corner of the material. So that's doing an XYZ probe. So let me just lift the bit up. And I'll put the probe back in place. And now I'm going to do just an XY.
Your bit's not above the circle, by the way.
Yeah, I know. I know that.
Bring it down one more. There, that's perfect.
Alright, so now I've roughly located above the circle again.
Oh, we lost our connection again.
Do we? Is the Wi-Fi here still working? Oh, maybe it's just your phone.
Right, keep going, keep talking.
Oh, okay. Let's see, what are people asking?
You don't need to click reset XYZ.
Yeah, you don't need to click anything. The act of probing sets the coordinate position. It always will set it for you. That is part of what the probing cycle does. Is it probes all the sides and it automatically resets your 0 to that corner point for you. So that will now be set. And if you want to ensure that that has been set properly, hit return to 0.
No. Give me connection, please.
Do you want to try using the webcam instead of the phone?
That's a bit of a more potato.
It is a bit more potato.
It's okay. I can do it. Just keep
Or
talking.
just like angle it. Oh. Hi. Yeah, so you never have to be setting any other buttons. You just hit probe and it will probe the surface. It'll set your 0, and if you want to double check that it's been set up properly, you hit return to 0. If you hit return to 0, it'll return to the 0 point that it had measured, and that you should find that that's at the very corner of the material. Okay, now I'm just going to show the other two probing types. Is there anything else on they said? Okay. So I'm going to switch over to just the X and Y. For the X and Y, you still want to make sure that you're located in approximately the same location, which is by the circle and a little bit above with your end mill. And I'm going to click, and if you remember, I set my settings here the same as how I set them in X, Y, Z, and also in the Z. I'm going to hit measure outside corner. Oh, hold up. This is wrong. Actually, this is a very good demonstration of the probing going incorrectly. You can see that it's hit an alarm because it's trying to contact the surface in a way that it expects to be contacting the surface, and since it isn't seeing the surface there, it's thrown up an alarm for me here. So this is actually a good chance for me to show you guys. When you get this alarm in UGS, basically for the machine's protection, it's going to not let you move, like not let you really do anything with the machine until the alarm goes away. To get the alarm gone, where is it? Where are my common actions? Oh, here. Go to the common actions tab, and there's a button that says unlock. You want to click unlock. By clicking unlock, that removes the alarm and it allows you to have control back over your machine. Okay.
You didn't set the settings on the for the XY.
I believe I did. I just think I can't exactly remember. I think I actually think I need to position the end a little bit differently. Let me see. In case you guys are wondering, I use the XY like once or twice, and this is gonna lead into me talking about like what probe, like when you're using certain probe types and why. So I'll explain that later. Let me see what happens when I do this. Excellent. So you probably saw I made a mistake. Okay, yeah, Josh, you got that right there. So yeah, you guys probably saw I made a mistake there. I forgot that when you're doing the X and the Y, probing on its own, you're actually placing the bit beneath the probe. You can set it quite low if you'd like to. Like I'll move it down a bit of a ways there. Let's see. Can I move the webcam a bit closer? I don't know.
Tilted this, yeah.
This way?
People want to see the screen, so I kind of had a bit here.
You can make the screen bigger? Okay, I'll bring this closer and you
I can make this smaller too. Oh no, don't go away.
There we go.
We need you.
Okay. Okay, this might be a bit tricky to see, but basically I positioned the cutting bit, and I'll remind you, this is for just X and Y that you have to do this. I positioned the cutting bit so that it's next to the probe, and it's lowered down, and it's kind of like diagonally next to it. And this is the point that you want to start the tool at if you want to be doing an XY probe. So I'm just going to, now that I've positioned it correctly, I'm just going to show you guys again from the closer perspective. I'm going to click measure outside corner, and you see that it's going to move to the side, touch the one face, move to the other side, touch the other face. So you can see it's very important that like it's offset from like diagonally from the probe by maybe 5 or 10 millimeters, and then it'll be able to seek in and find those dimensions for you. When you do this sort of probing, you don't want to take the probe off and immediately hit return to 0. Is your phone working again?
I think so.
Okay, can you get nice and close on that? So I don't want to immediately hit return to 0 because you can see that the bit is actually beneath the surface of the material, and we haven't probed the Z, right? We've just probed the X and the Y. That's what we just did. We only have probed the X and the Y. So we don't know what the actual Z height is. So what I'm going to do is I'm going to raise the Z up, and I'm just going to like, usually you'd have a certain Z height that you've already set, which is why you're only probing the X and the Y, but I don't, so I'm just going to 0 the Z just to make sure I don't run into the material. But now I'm going to hit return to 0, and you can see that it hasn't set the Z because, you know, I haven't measured the Z, but in terms of the X and Y, if I bring this down, it's found that corner in the X and the Y. And in case you guys need a refresher on the coordinate system, the y-axis is the in and out, and the x-axis is the side to side. So this is measuring it in the x-coordinate, and this is measuring it in the y-coordinate. Okay. Now I'm going to do a Z probe. The Z probe also has a slightly different position. It actually can have two possible positions for the Z probing. Move this back. So the first type of Z probing is very similar to the XYZ in that you just want to roughly place the bit over top of your touch probe, except for the Z probe, it doesn't need to touch where the circle is. It can touch anywhere on the surface of the plate. All it's doing is, because we know the thickness of the plate is 15 millimeters, and the plate is sitting on top of the material, we just need to touch anywhere on top of the material, and we'll know that wherever the top is, if we subtract 15 millimeters, then we know where the top of the material is.
You can flip it over.
Yeah, I'll show that later.
You can put that on wherever you want.
I'll show you later. So in this case, I'm just going to put it on the corner just to probe the Z. So in UGS, I'm going to hit the initiate probe for the Z tab. There we go. And now, you want to get it closer on that. And now I'm going to, oh, did you make this smaller again? Here, I'll make this a little bit bigger. Like that. Okay, and now that I've probed in the Z, I'm just going to show you that when I tell it to return to 0, it's going to bring the bit down right to the surface. See? It's right there at the surface. So that's a successful Z probe. If my probing is not happening near the corner, it's happening maybe somewhere near the center of the material, then you do a slightly different configuration. I'll show you that as well. So obviously, if I have this probe, the 15 millimeter dimension is this dimension here, but there's a lip, right? So if I try to put it like this on top, the distance from the top here to the material is no longer 15 millimeters. It's actually 20 millimeters because this lip is 5 millimeters in thickness. So I don't want to change my Z probe setup because I've already got it set up for the 15 millimeter spacing. So what you actually do, can you point it nice and close here, is I just flip it over. I just flip over the probe, make sure the banana plug's still in there. I just flipped it over, and I'm just going to touch anywhere inside of this lipped area here. Obviously make sure your magnet is stuck back on. And now back here in UGS, I'm just going to hit to initiate the probe again.
You get an alarm?
Oh yeah, I did.
It might be because your Z height is too far. You might want to...
Oh yeah, I was too far offset. Yep. So it was only seeking for the top of the probe. Like if it feels like it's traveled too far to seek to find the probe, then it'll give you an error and say, I don't know if like the probe's actually there. I don't know if I want to keep moving, so I'm just going to stop. So in that case, you get an alarm. You can also see down here, alarm probe. So I'm just going to unlock that. I'm going to move the Z height up a bit, but just make sure I'm not offset by too much here. And I'm going to go and initiate it again. There we go. And now I'm going to remove that.
You want to move it off the machine because if you run it forward and it hits the wire, it'll do bad things.
Yeah, like if you're starting an actual job, make sure this is out of the way. But if you can focus in on that again, I'm going to hit return to 0. And you can see the bit is right at the top. Now, I think this is a little bit off the top, like further off the top than it should be, just because this is a 2x4 and it's not very flat, as you can see. But if the top of your material is flat, then this would give you a very accurate reading on the surface of that material. Okay, so when would you use these 3 different types of probing setups? Because they are all measuring different things. You can measure all 3 coordinate systems, or the X and the Y on their own, or the Z on its own. So like, why would you choose one over the other? And are there circumstances where you might not use any at all? Well, I'll try to give you my best explanation on like when I would use a probe and when I might not even use a probe at all. So if I am cutting out of sheet material, like something like this, for example, where I'm actually going to position, like I just want to, like, let's say I'm cutting out this star guy here, which I'm going to be showing you in a minute. If I'm not trying to put them at the corner here, right? There's a screw here, and like this is a very large sheet. I can choose anywhere that I want to put them, right? And so if I'm setting up a job like this on a large sheet and I don't really care where it ends up, I can just navigate, like I can just jog the machine around and just place the bit roughly somewhere. Like I can just jog, like let's say I'm just going to jog over here and jog over here and lower the bit, and like let's say I want my star guide to be here, then I can just like finish bringing the bit down. I like to use the pulley here to get it, and you can feel like when it's touched the top of the material, and then I just reset 0 in UGS. Like that is now the cutting point that you can start at, and my star guide, because I've set I'll show you how I set it up in the program, but because in the program I've set the origin as the corner, the star guide is going to get cut out in this area here now. You know, that doesn't require any probing at all. And obviously it's not exact, but you know, this plywood is a little bit warped, and I'm sure it's not an exact thickness, etc., etc. So trying to probe the exact top of it might not even make any sense. And trying to position it in the X and the Y also might not make any sense, you know? So that's one of the situations where you don't even really need a probe to set it up. If you do want to get a slightly more accurate reading on the top of a surface and you don't want to use a probe, you can use a piece of paper. And so you can just raise it up by hand, put the paper underneath, and kind of keep moving it back and forth as you slowly bring the bit down. And then as soon as you feel it catch on the paper, then you know that the bit is about 0.01, like 0.1 millimeters approximately off the top of the surface, which is close enough that you can start your job, you know.
It's 5:06 now. I have to go soon.
Oh, yeah.
Do you think you can wrap this up in 10 minutes?
I suppose. Okay, yeah. Let's try to go. We'll have to pick up the space, I suppose. Okay, so to finish on probing. Sorry guys, we're gonna make sure that Andy gets to his thing on time. So if there's anything I can't cover here, we'll try to cover it next time. So to finish on the probing, usually when you're using just the Z probing, it's because you've changed your bit, and so the bit is now at a different height, but you want to maintain the XY position of the machine, because let's say you do a rough cutting of like a 3D surface with a larger bit, and then you want to do the finishing cut with a smaller bit. All you need to do is switch out the Z height, like change to the new Z height of the smaller bit. So that's when you would use just the Z probe. If you've got a piece of material here and you would like it so that it's, you know, more or less accurately placed at the starting point is more or less accurately placed at the corner, then that's when you would do an XYZ. In terms of when you would just do an X and a Y, it's really, really rare. Like I can say from personal experience, I've never used it. A lot of the times, these probing functions come in a lot more handy when you're actually doing like milling work on larger CNCs, and you're doing a lot of metalworking and stuff, and you're trying to actually locate geometries in the existing part. But when it comes to woodworking, a lot of the times we're not doing any complex fixturing or locating or anything like that. And so most of the time it's really good enough to just occasionally do an XYZ, occasionally do a Z probe, and that'll get you 90% of the way there. So that's that. All right. Let's see. Doesn't go up. Okay. Spittle is running. Does the job go deeper or go up at first, then go to its first location? Oh, okay. I will show you this when I'm running this G-code. Okay. So we're going to switch back to my screen, and I'm going to show you as quickly as I can what I'm going to set up for you here, which is this star guide that I've modeled out. So I'm going to go to CAMLab. So I'm going to just fly through this, but I can give you guys more of an explanation in session number 2, I think. One thing I wanted to point out really quick. If you ever are feeling anxious about moving your machine around, I should let you guys know that if you run the machine into its limits, it doesn't affect the machine at all. It'll make a bad noise, but it doesn't affect the machine at all. Let me just do that here for you now. I'm just going to intentionally run it into the side. It just makes this noise. And this is because we've designed the machine in a way so that it has enough torque to cut out a lot of awesome stuff, but at the same time, if you accidentally run it anywhere where it's not supposed to go, like even if I run it up in the Z or whatever, it's not gonna ruin your machine. I just wanna tell you guys that because I feel like that would make you feel more comfortable working with it. We've never broken this machine. Like the Longmill doesn't break. The only thing that breaks on it is the end mills. And so I hope you find that reassuring. But anyway, I'm gonna switch back over to this because I need to go fast. So I'm just going to set my machine to the Longmill. I'm going to be importing my surprised star guy that I just modeled up, and I'm going to set the cutting location as the corner just by toggling the check box here, and I've set it as a 1/4 inch end mill in the tools here. And all I'm going to do is just a roughing. For woods, I tend to use like a 0.45 in the roughing, and I'm actually just going to enter in whatever I want off the top of my head. And the reason why is I'm just trying to show you guys that this machine can be very forgiving to use. So I'm just going to do that, and I'm going to generate. And now you can see it's got all of those lines that it's going to follow in order to cut things out. I'm going to export the code, save it as prized starman. Okay. Then I'm going to navigate to it in UGS, open up my surprise starman, and you can see the visualization is popped up here. So now I'm gonna bring the cutting head. Let's make them right next to our other surprise starman over here. You mind switching to the phone view just so you can getting closer?
I have a dog on my lap.
Oh, okay. I'll try to move this closer then. Okay, I'll bring this. Tell me if things are in view. I can't really see if it's looking in the right place. And I'm going to bring that down. And I'm just setting this up the same way I showed you. You can see even the plywood isn't super well supported, but it's going to be doing, it's set up well enough. And then over here, I'm going to reset my 0 point. You could also click all of these to reset it. So now you can see in the visualizer that my bit's starting here. My Starman is going to be over here. And you can see that I've got space for my Starman there. And I've just got the router set on like 3.5 or 4. And so I'm just going to, well, before I start the job, I'm actually going to raise the z-axis up. I tend to raise the z-axis up before the job starts, because when the job starts, it's going to move in the x and the y first, and then it's going to drop down in the z to start cutting. So I tend to 0 it, raise the z up, start the job, and then it's going to move to its position and move down and start cutting. So you can see it's raised up. I'm going to put the dust shoe on. And I'll stick the hose on.
Here, give me the camera.
And I'm going to turn on the vacuum. And turn on the water. And then I'm going to hit play. Can you focus in on that? Look at that. I got my Starman. He's very surprised.
Super Mario called, they want their...
So, I'll have to wrap it up there, but I hope you guys can see how forgiving the machine is. Like, I really would encourage you to try to go out and just start trying something. And like, as I said, the machine, it can run into its limits and it's not going to break it. Someone asked, does it affect the coordinate system? Yes, it does, because the machine doesn't know that it's, like, it thinks it's still moving, but it's not moving. So you need to make sure that you do reset the 0. But you can see I kind of was able to just toss in almost any speeds into the program and run it, and you know, it spit out something that looks pretty nice. It's a little star guy, and yeah, so that's basically it. I think I'm not sure when our next live stream will be, but but I'm sure we will let you guys know, and I'll use that as a chance to maybe answer any questions that come up from this video, or to dive a little bit deeper into showing how to use a program like CAMLab in order to make cool stuff like this. Yeah, so I think that's everything. Thanks for coming by. And Andy, do you want to say goodbye?
Goodbye.
See you guys.